Alright, today we are doing the second part of our goal. So that was Unit 5, Goal 1 that we're on. And this is still working with functions, and so this continues that operation with functions. And we're going to look at inverse functions and relations. So we're first going to find the inverse of a function, and then we're going to verify that two functions are either inverses or relations. So inverse relation just is like we know of some inverse operations like multiplying and dividing and adding and subtracting. So inverse relation is kind of that same thing, that if you put in one input, you get out an input, and if you put in that output that you got out in to the next one, it should get me what I started with. So here is an inverse relation. A and B are inverses because you see A is the 0.15 and B is the exact opposite, 5A, or 5.1, and 26623773. So we're just kind of flipping that X and Y. And what you see on there, so our inverse relations of this would be 3.1, 3.6, 0.6, and 0.1. So if I look at that on a graph, and on the homework it does ask you to graph your functions, but you don't have to. I just want to show you what happens on the graph, and kind of shows you a little bit of where this would apply in a job field with some graphic animations. So at the 0.13, originally 6.3, 6.0, and 1.0. So I get this rectangle here. My new points are 3.1, 3.6, and 0.6 and 0.1. So again, we have that rectangle, same size, but it's reflected, and what it's reflecting over is this y equals x line. So if I'm wanting to reflect something in this manner, I would have to use that inverse relation. All right. We're going to go on to the next part. So functions work the same way. The inverse function would be is if I put in a 6 into this, I get a 2. And so the inverse function, then if I put in this 2, I should get a 6. And we represent inverse functions. This is going to be important because this will be something that you'll question later, as the function name, f or g or h, to the -1. That just shows us that that's an inverse function. So we're going to do it kind of the same. We aren't going to graph, but you just know that that will flip over that. So here is my inverse function, and I can rewrite this as y to the -1/2 x plus 1. And we saw that for the relations, we just switched the x and y, so we're going to kind of do the same thing here. So wherever my y is, I'm going to put an x, and wherever my x is, I'm going to put a y. And I'm going to solve for y, because I'm writing a new equation. So subtract my 1, multiply by the reciprocal of -1/2, and I get y equals -2 times the quantity x minus 1. And I want to go ahead and distribute that out. So y equals -2x plus 2. And we don't want to leave it as y equals, because that's just any line. We want to show that this is an inverse of this. To just show that, I need to write it in inverse form, function inverse. So f to the -1, f because this was f, so this is the inverse of f, minus 2x plus 2. So if this was g, I would put g to the negative 1. So that's how we find the inverse. Right, and next we're going to look at verifying if it's an inverse. So if two functions are inverses, if and only if, so if the composition of f composed of g equals x, so when I simplify down, I just get x, only x, nothing else, or g composed of and g composed of f equals x. So I have to be both, and I need to check both. But if both of them simplify down to x, then I can know that those are compositions of each other, or inverses of each other. So to check to see this, I would look at f composed of g. So I'm going to take the f function and compose it with the g function in for x. And we did compositions in part 1. So distribute this 3/4. 3/4 times 4/3 is x, or 1. 3/4 times 8. 3 times 8 is 24, divided by 4 is 6. 6 minus 6 is 0, so I just have x. So we see that the f composed of g equaled x. So now we check if g composed of f equals x. And 1 can not equal x, so make sure you check both of them. So now I'm doing g composed of f, so I'm composing the g function with f in for x. So 4/3, where that x is, I'm going to put the f function. Again, distribute, I get x. 4 times negative 6 is negative 24, divided by 3 is negative 8. And negative and positive make 0, and I get x. So yes, it's an inverse. And if it didn't, I would put no. Alright, so that is the lesson on what you're doing. Again, you don't have to graph, and I hope you have a good day.